Okay, so we're going to do a couple review problems to see if we can kind of get a handle on some of the confusion. So, this is a quadratic equation. I know that because the x is raised to the second power. Now, there's some extra stuff going on here, but there's a second power near the x, which means it's going to be a quadratic function. Okay, so it is already set equal to 0, which means we are going to find the 0 of this function. And to do that, we've got to get x by itself. And so ultimately, we're undoing, okay? So even if we think about regular equations, if we think about PEMDAS, you may remember when you learned how to solve linear equations, you were doing PEMDAS backwards, or some people learn it as SADMAP. So we're going to undo addition and subtraction. Same thing goes with this kind of a problem. So I'm going to subtract 4 from both sides. And when I do that, I get negative 3 times x plus 2 squared equals negative 4. Okay, so, and you might say, oh, but there's addition in there. Yes, but you kind of remember the onion. I've used that analogy before. When you're solving, you're trying to peel the layers. So you have to peel outside and then get to the inside. So now I'm going to undo multiplication or division outside of the parentheses. So I'm going to divide both sides by negative 3. And when I do that, these cancel, and I get x plus 2 squared equals a negative divided by a negative is a positive, and so we get 4/3. Okay, well, now what I'm going to do is I've got to get x by itself. And to get into this, I have to undo my exponent. Okay, that's the next thing in line. So we undid this. Now we've got to undo our exponent. The opposite or inverse operation of squaring is square rooting. So I'm going to square root both sides. Over here, what ends up happening is the square and the square root kind of cancel each other out. And so over here, we're left with x plus 2. But over here, we've got something different, okay? So first of all, we have to remember that if we take the square root, or if we square something, so if I did 3 squared, that's equal to 9. But the other thing that's squared, that would still give me 9 is negative 3 squared. That still gives me 9. And so we have to keep that in mind here. So x is being squared. So this could have been a positive or it could have been a negative. So when we do the inverse operation of squaring something, we have to put a plus or a minus over here. This could either be a positive number or a negative number. And so I am going to, because there's no real nice fraction that's going to come out of that. They're not perfect squares. It's just not nice. So I'm going to take the square root of 4/3, and it's only going to give me the positive square root, and that's okay. We know that it's positive or negative. And so we get, I'm going to round to the nearest, let's say 10th, why not? 1.2. Okay. Now, again, another reason for the plus or minus is remember that a parabola is going to cross the x-axis, or generally will cross it 2 times. And so we have to think about both of the sides that it could be on. And of course, there's exceptions to every rule, right? Okay, so now I want x by itself, so I'm going to subtract 2 from both sides. And what I get is something kind of interesting. What I get is I get negative 2 plus or minus 1.2. And I always put the plus or minus second. And the reason why is because this spits out 2 possible answers. So what we have here is we have potentially negative 2 plus 1.2, okay? And then the other answer we could get is negative 2 minus 1.2. So if we do negative 2 plus 1.2, well, that's going to be negative 0.8. And negative 2 minus 1.2 is going to be negative 3.2. So those are the 2 possible answers. And what these answers mean is negative 0.80 and negative 3.2. 0.20 is where this function would cross the x-axis. Okay, so that's a quadratic equation. Now, let's go ahead and try a radical. So here's an example of a radical, okay? And it doesn't have too much going on if we really think about how complex this problem was. So this one, why I say it doesn't have much going on, is because up top we had to get the square all by itself. And so we call that isolating the square. Well, here we're going to isolate the radical. Okay. And so that means we want to get the radical alone on one side. So if something was multiplied or divided or added or subtracted, we would get rid of that. Well, it's all by itself. And this, don't forget, is still inside the radical. So that's good. Step 2 then is to undo the radical. And remember, you undo by squaring. So I'm going to square both sides. Now up there we had to keep in mind the plus or minus. Radicals are not the same, okay? A radical function looks very different, so we don't have to do that. So now these two things undo, and we're left with x minus 7. 3 squared is 9, and then I get x by itself by adding 7 to both sides. Sorry about that. And I get 16. Okay. Now, what's really important is that before we walk away from this problem, we check our answer. Okay. And so what that means is I'm going to take x equals 16 and I'm going to plug it into my original equation. So the square root of 16 minus 7 equals 3. Well, 16 minus 7 is 9, and the square root of 9 is positive 3. Okay, and so this one does check. Sometimes when you plug this back in, it won't work, and those are called extraneous solutions. They don't happen that often, but that's why you always want to check, because sometimes you'll do everything right up here and something weird will work out down here. It won't actually come out to something that's equal. Okay, last but not least, let's go ahead and try a more complicated radical problem. So this one has kind of all the bells and whistles, right? We first still have to isolate the radicals. We've got to undo this and undo this. Same thing as the first challenging problem on the other side. We're going to undo PEMDAS. And so we're going to undo addition and subtraction first. So I'm going to subtract 8 from both sides. And I get 2 root x plus 5, those go away, equals 10. And then I want to undo a multiplication or division. So I'm going to divide both sides by 2. And that works out nicely. Nice numbers. And remember, decimals are fine too. It doesn't mean you did something wrong. And then we get root x plus 5 equals 5. And now we're going to undo our exponent. And interestingly enough, the square root of something is the same as raising something to the 1/2 power. You don't have to worry about that, but it's just an additional notation. So some people might say this root is not an exponent, but it actually is. So I'm going to square both sides. When I do that, I get x plus 5 equals 25 minus 5 from both sides, and I get x equals 20. Well, that looks pretty good. I'm just going to make sure by checking my work in my original problem. And you can kind of like do it off to the side. It doesn't have to be super detailed or anything. So we have 2 root 20 plus 5 plus 8, and we're going to see if that gives me 18. Well, that's 2 root 25 plus 8. That's 2 times 5 plus 8. And that's 10 plus 8, which, why, yes, it does work.